In the previous classes, we have seen the concept of multiplexer and also we have seen the concept of demultiplexer, right? So multiplexer means which is going to take 2 power n lines as input and it is going to produce one line as output, right? How it is producing one line as output? Based on the n select lines, right? Similarly, if you take demultiplexer, which is going to take n lines as select lines and it is going to produce 2 power n lines as output lines by taking one input line. Means whatever input that you are going to give, if it is redirected to 2 power n lines, it requires to have n select lines, right? And also we have seen various kind of Boolean function realizations, right? So Boolean function realization means if I am going to give some kind of expression in the form of min terms like 0, 1, 4, 5, how to construct this all using multiplexer as well as demultiplexer. And also we have seen various kind of actual real-time examples like full adder, half subtractor, full subtractor, like that, right? Yes. And also we have seen various kind of gate questions regarding this multiplexers concept. Okay, fine. Now in today's class we'll see one more concept, that is decoders. Guys, decoders is an example of what kind of circuit? Combinational circuit, right? So earlier we started with the combinational circuit and we have seen various kind of examples of combinational circuit, right? Among those, one kind of example is arithmetic circuits, right? Various kind of code conversions, something like code conversions and something like multiplexers and demultiplexers, and also we have seen one more terminology called decoders as well as encoders, right? So now in today's class we'll see the concept of decoders, right? So decoders is a kind of a combinational circuit. Means is it going to have any kind of memory element? No. Combinational circuit means which is going to take the present input and it is going to produce only the output, but it is not going to depend the present output on the previous outputs, right? Yes. So decoders means it's a kind of a combinational circuit which is going to take n lines as input and it is going to produce 2 power n lines as output. 2 power n lines as output. Okay, fine. So like if you are going to generally observe the structure of the decoders, we can represent like this, right? So basically n by 2 power n decoder, right? Means it is going to have n lines as input and it is going to produce 2 power n lines as output. So this is a general meaning of decoder, right? So in the real time we have various kind of advantages. Okay, before going to see those advantages, let's see how it is going to work, right? So basically if I am saying it is n by 2 power n, if you place n value as 1, what kind of decoder is going to get? 1 by 2 decoder is going to be get, right? Means that the circuit contains one line as input and it's going to have 2 lines as output. This is what I can call it as 1 by 2 decoder, right? Means here whatever the input that you are going to give, like for example if I am going to produce here the input as I and that input is going to be redirected to either O0 line or O1 line. Right? For example, if I am trying to define the characteristic table for this, right? So the I value is ranges from which to which value? As we are going to have only single variable, it is going to have two possible values. One is 0 or one is 1, right? So at the output line O0, if input is 0, O0 output is 1 and O0 output of input 1 is 0. I hope you understood, right? Meaning that here if I pass 0 as input, the output will be generated at the O0. If I pass 1 as input, the output will generate at the O1. So that is the what I am writing. If I am going to have to define O1 output, if I is 0, my output is 0. If I is 1, my output is 1. Right? So how can we represent basically this as O0 equation? O0 equal to I bar. Can I write I bar? Similarly, if I take O1, is it look like a kind of I or not? So basically how you write? With the help of K maps. You can take out some K maps and you can write that, right? So which you can able to directly understand, right? So can you draw the circuit diagram for this? If I am going to have input I, so which is going to have what you require? I bar, right? I bar is something like O0, and its respect to I, you are going to produce at the output as it is. This is what I can call it as 1 by 2 decoder. Means if you are able to observe here the structure, it will look like this, right? Means here whatever the input that you are going to pass, that will be produced as output based on the input what you are passing, right? So if you are going to pass here 0, 0 will be converted to 0 will be passed through NOT gate. So here you are going to get 1 and here you are going to get 0. So that means if I am going to pass 0 here, what is the outputs we are going to get here? 1 and 0. 1 and 0. Similarly, if you are going to pass 1 at the output O0, you are going to get 0. At the output O1, you are going to get 1. As it is, right? If I am going to give 1 as input, at the output O0, you are going to get 0. At the output O1, you are going to get the value as O1. This is the way your 1 by 2 decoder is going to be work. Right? Similarly, if I take 2 by 4 decoder, right? So in 2 by 4 decoder, you are going to have 2 input lines, right? 2 by 4 decoder, 4 output lines are there. Like let us take O0, O1, O2 and O3. Let me call them here as I0, I1 and I0. See, this representation is not compulsory as it is, right? So it can be represented based on the truth table. So in the truth table, how you are defining, based on that you can make the representation here also, right? So now tell me how it is behaving. If I am going to give 0, 0 as input, you are going to get the output as O0. Meaning that if I am going to give 0, 0 as input, at the output O0, your circuit is going to get the value 1 and all the locations you are going to get the value 0. Right? Similarly, if you are going to give 0, 1 as input, 0, 1 is input, O1 is going to be selected and its respective thing. Right? So if I am going to draw the truth table for this, I1, I0. So the positive values are 0, 0, 0, 1, 1, 0, 1, 1. And respective output lines are O1, O2, O3, O4, or it may be like the general representation O1, O2, O3. Okay, so when you are going to get the high output at O0, when you are going to pass the 0, 0, and for the remaining cases you are going to get zeros. 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1. This is the way your 2 by 4 decoder is going to work. But what about the case for 1 by 4 demultiplexer? What is going to do? If I am going to have a demultiplexer of size 1 by 4, you are going to have 4 output lines, 1 input line and 2 select lines, S1 and S2. S1 and S1, right? So is it look like kind of 2 by 4 decoder? Yes or no? How? Can I? Yes, very good. In place of selectors, can I write as I1 and I0? Yes, right? And in place of this I will simply pass the value as 1. Is there any change? Right? If you are able to observe, guys, the 1 by 4 demux truth table, what you are going to mention? S1, S0, O0, O1, O2, O3, S1 S0 is 0, O0 value is what? 1 or I. O0 value is I, and all the remaining 3 are zeros. In place of 0 1, 0 I double 0, 1 0, 0 0 I 0. In place of 1 1, you will get as 0 0 0 0 I. So I hope you understood the difference between these two now, right? Means that in place of decoder, if you are going to provide certain input, it is going to produce the high output at the respective location. High output means what? It is going to produce the value 1 at the respective location. Whereas coming to demultiplexer, based on the select lines, it is going to pass the respective input. Not it's like a 0 or 1 or whatever value it may be, right? So that's the reason I mentioned here as I. I means what? Whatever the input that I am going to pass here, that input will be redirected to the respective location. That's the difference between demultiplexer as well as decoder, right? Meaning that, so if you would like to get a 2x4 decoder, can I get with the help of demux? What you can do? You can simply make the select lines as input lines. Simply take the select lines as input lines, and what about the input? Input I am going to make it as 1, right? That's it, right? So then the 1/4 demux can be worked as 2/4 decoder only, as well as like 1/8 demux can be converted to 3/8 decoder also, right? So if you are going to define the O0, what is O0 now? O0 for decoder. What is O0? I1 bar, I0 bar. Similarly, O1, I1 bar, I0. O2 is I1, I0 bar. O3 is I1, I0. Simply you can construct the basic circuits, basic logic gate circuit, right? So you can able to construct it. Okay, with the help of these O1, O2, O3, O4 as the outputs for the given inputs. Okay, fine. So basically, if you are able to observe, all these are what? Various kind of minterms, right? Minterms means they are going to represent in the form of sum of the products, right? So means in decoder also, we can able to represent all possibilities of minterms. As I can able to represent all possibilities of minterms, I can able to construct any kind of Boolean function. For example, if my Boolean function contains the minterms are 0, 2, how we are going to construct? So you can take here, what kind of decoder required? Is it 1/2 decoder is enough? 1/2? No, because you required here 2/4. The reason is when you are going to have 0 and 1, you require only 1/2 decoder, but here the outputs are 0, 2, means that ranging from 0 to 3. So that's why you required to go for 2/4 decoder, right? So here you are going to have 2 inputs and 4 respective outputs, right? So if I am saying that this is I1 and I0, so at what lines you need to get the output 1? You need to get the output 1 either at the 0th location or at the 2nd location, right? So basically we can do like this. I can make this, right? This is what I can call it as actual output for the given Boolean function. So I can represent in the form of f of x comma y, right? If I am saying that this is a kind of f of x comma y function, right? What is the meaning of this one? If I am going to give 0 0 as input, I require to get the output 1. Is it producing the same thing or not? So what are the minterms reference? For 0 or 2, I need to produce the value 1, and for 1 or 3, I need to produce the value 0. Right? Now try to calculate this, right? If I am going to give 0 0, high voltage will be passed to which one? First line, right? As high voltage you are getting, the OR gate, one is 0 voltage, another one is high voltage. So you are going to get the output as high voltage. Can I call it as 1? Yes. Similarly, if I am going to have 1 1 as input, one has input. Which line is going to get high voltage? The respective line, this line is going to get high voltage. But is it connected to any circuit? No. So here at the output line, you are going to get 0 as output. I can call it as low voltage. Right? Similarly, can you draw the circuit for example, f of x comma y comma z equal to sum of the minterms are 0, 2, 3, 4. Can you able to draw by yourself? Yes, you can draw. So what kind of decoder is required here? Is 2x4 decoder is sufficient? No. So we'll go with the next level, that is 3x8 decoder. 3x8 decoder, where you are going to have 3 inputs. One is I2, I1, I0, and basically we are going to have 8 output lines. So 0, 1, 2, 3, 4, 5, 6 and 7. At what lines you need to have the high output? You need to have either at the 0 or at the 2, 3 and 4, right? And all the remaining cases you need to have only the output as 0, right? So here you have to require the output as in terms of f of x, y, right? This is the way you can able to use the decoders, right? Similarly, can we able to implement the full adder? So you can implement the half adder also. You can able to implement half subtractor, full subtractor as well as. I would like to implement here full adder. How can you implement the full adder? What are the minterms for full adder? Especially for sum and for the carry. For the sum, the minterms are 1, 2, 4, 7. Very good. For carry, 3, 5, 6, 7. 3, 5, 6, 7, right? So what kind of decoder is required here? 3x8 decoder is enough, right? So when we are going to have 3x8 decoder, we are going to have the inputs I2, I1 and I0. The output lines are ranging from 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7, right? So to get the sum, I need to connect with the either 1, 2, 4 and 7. 4 and 7, you are going to get the output as sum value, right? Similarly, can I do the same other function here itself? Yes or no? We can do, right? So if we take the carry will be 3, 5, 6 and 7. This will be the carry. This will be the carry, right? Now try to solve by taking certain example. For example, my input is like 1, 0, 0. What is the sum you required? 1, carry is 0. 1 plus 0 is 1, 1 plus 0 is again 1. So sum will be 1 and carry will be 0, right? So if I am going to pass 1, 0, 0, where you are going to get the high output? You are going to get the high output at the 4th line. At the 4th line. As you are going to get the high output at the 4th line, here you will get the high output. So for the OR gate, high output if I am going to get, here you will get the 1. And is there any inputs are given for this one? No. So you will get the value as 0. Value as 0, right? Similarly, if you go for 1, 0, 1, what is the output for 1, 0, 1? You will be 1 plus 0 is 1, 1 plus 1 is 0, carry will be 1. Carry will be 1, right? So if I am going to give 1, 0, 1, which line is going to be like highlighted? 5th line is going to get high input, high voltage, right? So that's different. Sentence you have to make it clear. Whereas coming to demarks, you are going to get the input. Here you are saying that it is high voltage, right? So at this particular line, you are getting high voltage. As you are going to get high voltage, here you are going to get the value as 1, and as no connections are there here, you are going to get the value as 0. Right? Similarly, For the coming class, try to do for half adder, half subtractor and full subtractor. We can do it as a work. Okay, fine guys. So whatever the decoders that I am trying to construct here to solve the Boolean functions, can I able to implement the same full adder with the help of the minimized decoder? Like here I am trying to construct full adder with the help of 3/8 decoder. Can I do with the help of 2/4 decoder? Yes, right. As like as multiplexers and as like as demultiplexers, here decoder also can be constructed with the lower level gates. Like for example, I would like to construct 3/8 decoder using 1/2 decoder. 1/2 decoder, right? Now, how many 1/2 decoders are required for you? It is as like as mux, right? So, trying to implement 1/8 mux using 1/2 mux. Observe here. So, first let us try to complete 3/8 decoder using 1/2 decoder, right? So, guys, if I am saying that is 3/8 decoder, how many output lines are there? 8 output lines are there, right? So, in order to get 8 output lines, how many 1/2 decoders are required? 4 1/2 decoders are required. Right? So, these are the various kind of decoders, right? So, if I say this is O0, O1, O2, O3, O4, O5, O6 and O7. Here for every 1/2 decoder, you are going to have one input, right? For the previous level, for the before level, what you required? You required to have again a 1/2 decoder, because we are trying to construct with only 1/2 decoder, and this 1/2 decoder is going to produce 2 lines as output, right? 2 lines as output, and this line is meant for the control of like if I am going to give some kind of naming convention as like 4, 5, 6 and 7. So here this 1/2 decoder, the second decoder first line is meant for the control of fourth decoder, and second line is meant for the control of fifth decoder. Okay. Similarly, I am going to use once again one more 1/2 decoder. Right. So here at the first decoder level, how many outputs you are going to get? You are going to get 2 outputs, and similarly here also you will get one input for all kind of decoders. Right. Now how you will give the connections to get the respective output? So meaning that if I am going to give for example 100 as input, which line need to be activated? Which line need to get high output? Fourth line. So meaning that O4 need to get high output line. So if I am going to give 100, you have to get O4 as the high output line. So how we are going to traverse? You have to define, right? So basically guys, try to observe, for every decoder or for any kind of circuit, there will be again one more line called enable line. What is the use of enable line? Which is meant for whether to switch on the circuit or whether to switch off the circuit. I can use enabler, right? So here I am trying to use the enabler to control the respective circuit. Just what is required here, I am not passing any input, I am just passing the voltage. That's why I am just simply activating it, right? So I can do connection like this. Right? Similarly, the output of first decoder will be connected to enable of the second decoder. Similarly, the output of second level of first decoder will be connected to enable of the third decoder, right? Now Here also you will have one enable line, right, which is going to be always 1. Am I right? Because to act this circuit perfectly, I have to make it always enable. Fine. Now, where should be right? Like if I am assuming that this is I2, I1 and I0, if you want to get O4 as output, what I have to do? Can I do like this? Can I connect like this as I2? This as I2, and I will make these two connections as I1, and I will make these connections as I0. Right? Now try to debug it. So I2 value is 1, I1 value is 0, I0 value is 0. Right? As I2 value is 1, which line is going to be activated? I2 value is 1, second line is going to be activated, meaning that output will be get here at the enable line. As you got the enable line at output, this circuit is going to be activated. This circuit is going to be activated, right? If this circuit is going to be activated, what is the respective input line? 0. 0 means again the top line is going to be activated, meaning that this enable is going to be started. If you got this enable, this circuit is going to be activated. And what is the respective input? 0 means this line is going to be activated. Are you going to get the respective output or not? Right? So this is the way your decoder is going to work. Right? So what about the case of 1/8 mux using 1/2 mux? You are going to have 1/2 mux. So this is as much as simple. 1/2 mux and one more 1/2 mux, and every 1/2 mux is going to produce 2 lines as output. Those 2 lines, one line will be connected like this and one line will be connected like this, right? Like that, right? And one more 1/2 mux is required, and it will be connected like this. And actual input will be available at the first location. And what about the select lines? You are going to have one select line here, and one select line will be connected like this. I can call this as S2, S1, S0, 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 and O0, O1, O2, O3, O4, O5, O6, and O7. If you are able to debug it, you are going to get the output 4. If I am going to pass 100 as input, you are going to get at the output O4 as I, not the high voltage. Not the high voltage. Whatever input that you are going to do, that input is going to be traversed to some lines. That is what mux or demux. Whereas coming to decoder or encoder, your input is not going to be traversed. Instead, high voltage is going to be traversed. Right? So try to make it 100. So as you got here 1, so if I say that this is S2, S1, S0, S2 1 means what? This circuit is going to be get input, and it is going to get here 0, right? So here, if you are going to get here, it will be again 0. 0 means first line. Again here you will get 0. 0 means again O4 is going to get. Okay, fine. Similarly, can we able to construct it for the another kind of requirement? For example, 4/16 decoder using 3/8 decoder. Right? So guys, what you can do? So here you require 16 output lines. So to get 16 output lines, you are going to have how many 3/8 decoders are required? Basically at the output line, output level you require 2. At the input level, you require one more 3/8, right? Okay. So 3/8 decoder is going to produce outputs ranges from O0, O1, 2, 3, 4, 5, 6, 7. Similarly, one more 3/8 decoder is required. These ranges from O8 and so on, O15. And instead of taking one 3/8 decoder, because if I take the 3/8 decoder, what will happen? All the remaining lines are going to be wasted, right? So here what you required? You required to control only 2 circuits, right? That's the reason I am going to simply use a 1 by 2 decoder. 1 by 2 decoder, and this output will be transferred to this one, and this output will be connected to this one. So and these two are enablers, as like we discussed, right? So here we are going to have one input, and here there will be an enabler. This enabler value is always 1 to make your circuit value as high, or if you make 0, your circuit always going to be in off state, right? Now what might be the inputs you have to give to work this circuit, right? So here as it is 1 by 2 decoder, here you have to give only one input. So let us take, if I am going to have 4 inputs, I am trying to give the naming as I3, and as it is 3 by 8 decoder, how many inputs you have to give? 3 inputs. So I will make it as I2, I1 and I0. Similarly, here also I will do the same connection, I2, I1 and I0, right? Make sure that this circuit will work as per your requirement. So this is the way you can able to implement 4 by 16 decoder using a 3 by 8 decoder, right? So guys, what is the next question we will get? How many kind of decoders are required if I am needed to construct one such kind of decoder? For example, if I am going to have again a 3 by 8 decoder need to be implemented, how many 1 by 2 decoders are required in order to get the requirement of 3 by 8 decoder? Obviously 7, right? So how it will be, right? For example, how we have solved earlier, how many multiplexes are required in order to solve 1 by m multiplexer like that, right? So if I would like to implement with the help of decoder, so here one device contains 2 output lines, am I right? Meaning that one line needed to define how many devices are required. Half decoders are required. Half size 1 by 2. But here my requirement is I want to get 8 output lines. In order to get 8 lines, how many decoders are required? 8 by 2 decoders are required. That means 4 decoders are required. For these 4 decoders, you are going to have again 4 lines. Again you are going to have 4 by 2 decoders are required. That means 2 decoders. Again you are going to have 2 lines. These 2 lines required to implement. So you required one more decoder, that is I can call it as 1 decoder. Can I stop here? Yes. So meaning that total how many decoders are required here? 7 decoders are required in order to implement 3 by 8 decoder, right? Similarly, can we construct for 6 by 64 decoder, and how many decoders are required of size 2 by 4? Right, basically how we will solve? So to get 4 lines, you require 1 decoder. Am I right? So here we changed the formula, right? 2 by 4, right? So 2 by 4 decoder required to produce 4 lines as output, right? So 2 by 4 decoder is going to produce 4 lines as output. So we required 1 decoder. In order to produce 1 line, you require to have 1 by 4 decoder. 1 by 4 decoder, right? But point is here, I need to produce 64 lines. So 64 by 4, you are going to have 16 decoders, right? And these 16 decoders again get 16 lines as output. 16 by 4 is 4. 4 by 4 is 1. So total how many decoders are required here? 21 decoders are required. 21 decoders are required. And how many levels are there? 3 levels, right? So this is first level, level 1, level 2 and level 3. Here also at level 1 we are going to have 1 decoder, level 2 we are going to have 4 decoders, and level 3 we are going to have 16 decoders, right? So this is what we did. At level 1 we require 1 decoder, level 2 2 decoders, level 3 4 decoders. Total you have got as 7 decoders, right? So can you able to generalize it? If I am going to have a decoder of size m by 2 power m, how many decoders are required of size n by 2 power n decoders? Can you define? So basically what we did here, so we are going to take, so basically 2 power n lines as output, which requires one decoder, guys. Instead of taking this much complexity in terms of powers of 2, what I can do now, I will try to modify this equation as like, can I write it as log m by m decoder? Yes or no? M is separate term, 2 power m I converted to m, right? So I taken logarithm on both sides, so I got log m into m by m decoder, right? Similarly, if I made like this, it is also log n by n decoder. Now it is easy for us to solve. It's like a kind of earlier mux concept. Am I right? So now tell me, if I want to implement n lines as output, how many decoders are required of this size? 1 decoder. If I want to produce 1 line as output, how many decoders are required? 1 by n decoder, right? As earlier example, right? Similarly, if I am going to have to produce m lines as output, you require m by n decoders, and to produce these m by n lines as output, you need m by n square decoders, and so on, right? So we are going to get n levels or k levels. After k levels, you are going to get the value as m by n power k, where this value will be definitely less than or equal to 1, right? If I am going to calculate this, k value is definitely going to be greater than or equal to log m to the base n. Is it correct? Log m to the base n, right? So means, what is the value of m here? We have converted, right? That you have to make understood, right? We have converted. So this formula is different from Mux formula. It may look like the same thing, but they are purely different, right? Because we represent the terminology same, different. Okay, fine. Similarly, for example, how many levels are required? K levels are required. K levels means, can I write it as summation of k equal to 1 to log m base n, and how many decoders are required? You can mention them as m by n power k, and that should be, it is also in seal form. This is the formula for to define total number of decoders required, right? For example, try to solve this one. If you want to implement a 3 by 8 decoder, using 1 by 2 decoder, how many decoders are required of size 1 by 2? So how many levels are there? How many levels you are going to get 3 levels. How you will get that? Right? It should be from k value should be greater than or equal to log m to the base n. Right? So can I write this as log m by log n. What is log m? Log m is 3. Right? So I have transformed the formula, right? This is log m by m. This is log n by n. Log m value is 3 and log n value is 1. So k should be greater than or equal to 3 by 1, that is 3. Right? So once we know the number of levels, can you able to calculate it? So I can make it as m by n. M by n is what? 8 by 2 plus 8 by 2 square plus 8 by 2 cube. So total you are going to get 7 decoders. Okay na? So here you have to make sure the difference. So earlier there is no meaning of log m, but here the log m is changes completely. You have to make sure it compare. Okay, so that's why I have taken an example also. So this is important. Okay, so I think we covered everything. For example, like let me take the advantages of these decoders. Right? What is one of the advantages of decoders? Can we able to implement any kind of logic circuits? Yes or no? We have seen various kind of examples, how to implement various kind of Boolean function, right? So that is one of the advantage of decoders. Similarly, we can able to perform various kind of conversion sum. So this is also one of the advantage of decoder. Like for example, I want to convert a number binary to octal. Binary to octal. See, conversions means all kind of conversions are not possible. There are some kind of conversions which are possible through decoders. Some kind of conversions which are possible through encoders. Some kind of conversions which are possible through multiplexing, like that, right? So some conversions are possible here, like binary to octal, BCD to decimal, like that various kind of conversions are there. Those will be supported by decoders. For example, I want to implement through binary to octal. How we are going to do? So in octal, how many output lines are there? 8 output lines are there. Octal representation, right? So if you are going to have, so you can able to implement with the help of 3 by 8 decoder. 3 by 8 decoder, right? So output is O0, O1, O2, O3, O4, 5, O6 and O7. And you are going to have inputs as I2, I1, I0. I1, I0, right? Meaning that if I am going to give 100 as input, what need to be my output should be produced? 4, right? So I am going to give 100 as input. I am going to get the high voltage at which level? O4. So can I say it is binary to octal conversion? Yes. Right? So you can able to do that. So can you draw the truth table for this? If I am going to draw the truth table, I2, I1, I0 and O0, O1, O2, O3, O4, O5, O6 and O7. Right? Inputs are 00, 001, 010, 011, 100, 101, 110, 111. Okay now, if I am going to get 000 as input, what need to be activated? O0 should be activated. That's why I made here as 1 and all the remaining are zeros. Similarly, 1 you got 01, 00, 4 zeros. When you got 2, you need to get the output at O2. When you got like this, you need to make sure to write correctly. O4 is going to be activated. When you got 101 at 5th line, it is going to be activated. When you got 6 as input, 6th line is going to be activated, and when you got 7 as input in the binary format, you are going to have 7th line is activated. So this is the way you can able to draw the truth table, right? So for this, can we draw the circuit diagram? Can you draw circuit diagram? What is O0? Can write O0 as I2 bar, I1 bar, I0 bar. Similarly, O1 is I2 bar, I1 bar, I0. O2 and so on. You can write for all the cases for the coming class and try to draw the circuit for this. Right? So circuit how are you going to get? You are going to take I2, I1 and I0 and all the inputs will be get like this. Right? Assume that it's a kind of 3 input AND gate. Right? If it is 3 input AND gate, the circuit is going to be differentiated with 2 input AND gate. Right? So 3 input AND gate, how we are going to construct with the help of 2 input AND gate? You require 2 AND gates. Right? So basically, if you take here, this is 3 input AND gate. If you want to make it equivalent with 2 input AND gate, it should be like this, right? The resultant should be connected with like this. That is the difference between this one, right? So that's why I specifically mentioned here it as 3 input AND gate, because every time we are going to take 3 input variables. Right? You can draw this circuit diagram for the coming class. Okay. Similarly, you can able to do construction for BCD to decimal also. In BCD, what are the valid inputs? Valid inputs are ranging from 0 to 9, and output is going to produce from 0 to 9 also. Right? So you can do that for your example. Okay. Similarly, you can able to use this decoder for the purpose of parity chakram. Parity checker. What is the meaning of parity checkers? Right? We can able to define whether it is an even parity or whether it is an odd parity. Right? So even parity, for example, if I am going to have the inputs like A2, A1 and A0, all the cases 000, 001, 010, 011, 100, 101, 110, 111, right? So if I want to say whether this input is even parity, what my output should be, right? So if I want to say that even parity, so is it like any kind of thing added here? No. So that's why I am making it as output as 0. And here to make it as even parity, I am going to add 1. Here 1, 0, 1, 0, 0, 1. Right? For this, can you able to draw the circuit diagram? If it is going to have 3 by 8 decoder, you are going to have 3 inputs A2, A1 and A0, and all the lines are going to be activated based on the requirement. So what are the values? 1, 2, 4 and 7. So for 1 you are going to get, for 2, 4 and 7. OR gate you are going to get, right? So now what is output you are going to get here? Output you are going to get 1. For any one of these inputs, like if you are going to simply take 0, 1, 1, 0, 1, 1, which means that line 3 is going to be activated. Line 3 is going to be activated, right? So 0, 1, 2, 3. Line 3 is going to be activated, meaning that for the output, what is the value you are going to get? 0. Means that is it an even parity or not? The given input is already in even parity. If I am going to get the output 1, I can say that the given input is odd parity. So this is the way you can able to define the one of the advantages for the decoders. Okay, fine. For example, try to construct the decoder for the input sigma of 0, 2, right? How many decoders are required of size 2 by 4? Only one decoder of size 2 by 4, right? If I am going to have two input lines, one is I1, another one is I0, you are going to have 4 output lines, O0, O1, O2 and O3. Okay, fine. Now, where might be your output need to be high? One is at 0 level, another one is at 2 level. You are going to define like this. So here you are going to get the Boolean function f of x comma y, right? The same circuit diagram I can able to redraw in another way. Instead of using OR gate, I can able to redraw in another way. Like, try to observe. I am going to use only 2 by 4 decoder. Input is I1 and I0 and outputs are like this. Okay, fine. Now instead of using OR gate, I I am going to place one vertical copper wire. Vertical copper wire. Okay. Assume that these horizontal are also copper wires. Right. Now, to get the output 1, for 0 comma 2, meaning that if I am going to get this line activated, or to get this line activated, I am going to pass the values from here. But for these two cases, only I need to get the function f of x comma y, means I need to get here high voltage. So what you can do? Can I make connection here? If I make connection, what will happen? Assume that four horizontal lines are there. If 4 horizontal lines, I have connected with some lines, right? If I am going to connect it, for example, with example I can say, right? If I am going to say it has 0, 1 as input, high output will be generated which line? Second line, meaning that my current is passed through here. If current is passed through here, if vertical is connected to that line, is it connected? No. As it is not connected, what might be the output you are going to get? Low. Am I right or not? Fine. So for example, if I am going to give the input as 1 0, which line is going to be activated? Second line is going to be activated, right? Meaning that voltage will be passed here. As voltage is passing here, this line is connected with another line, that is vertical line. So it can able to pass the same high voltage to this particular line also. So it is going to produce high output. So this is the way also I can able to write. Meaning that if I want to define one function, basically in decoders you require one OR gate. Similarly for this kind of representation also, in order to represent one function, how many vertical lines are required? You require one vertical line. Okay, fine. Suppose for example, I want to construct 3 functions like 1 comma 2 and minterms of 2 and minterms of 0 comma 1. Right? So can I able to implement with the help of a single 2x4 decoder? Yes or no? So basically what you will do, you can take simple 2x4 decoder and it is going to have 2 lines as input. One is I1, another one is I0, and it is going to produce 4 lines as output. Right? You can draw the circuit diagram for this. Right? So meaning that I am going to take simply 1 comma 2 and I am going to make it with OR gate. Right? So instead of that, what I can do? Can I take one vertical line and I can take another vertical line which is meant for another function. I can take with another vertical line which is meant for the another function. For example, let me call this as a function f, g and h. Right? So for the function f, I have made one vertical line. For the function g, I made one vertical line. For the function h, I made one vertical line. Now where we need to make link both horizontal line as well as vertical line? For function 1, I need to make it connection at the line number 1 and at the line number 2. Similarly, for the function g, I am going to make it connect at the line number 2. Link at the line number 2. Similarly, for the function h, I am going to connect at the line number 0 and at the line number 1. Right? For example, I would like to get the output 1 for the function g. Right? So for the function g, what is they are expecting for 2, right? 2 means what? 1 0. 1 0 means power is going to pass it to the third line here. Right? At where they are connected? At this particular point as well as this particular point. Right? So when it is connected at these two particular point, what about the g function? Is the g function is going to get the output or not? Yes. So g function is going to get output. So I can say that I can able to implement all the things. Okay, fine. So meaning that simply if I are able to observe, you are able to observe, I am going to have a data like 0101, 1010, 1011 and something like 0011. Right, the same thing I am going to write in the form of some kind of matrix format. I have four vertical lines, right? So here, so assume that this is a function f g h I. Let us assume, right? So if I would like to represent this data, how can I represent this particular representation? Can I represent here 1? Wherever link is connected, power is going to be transferred. Wherever 1 is there, power is going to be transferred. Similarly, for 1010, here the link should be existed. Here the link should be existed. Similarly, for 1011, link should be existed, link, and there will be a kind of a link. Similarly, for 0011, the link should be like this. Am I right? So it's a kind of a simple matrix representation, right? So when you are going to give the power to this one, if I am going to connect it to a 2x4 encoder, 2x4 decoder, your power may get at respective lines, right? Meaning that I am going to have two input lines. One is I1, another one is I0. Right? Now try to observe. I am passing simply an input as 10. An input as 10. When I am going to give input as 10, your current is going to be passed at this particular line. Power is going to pass at this particular line. If power is going to pass at this particular line, where you are going to get high voltage? You are going to get the high voltage here. I can call it as 1. And at the second line, are you going to get any voltage? No. And at the third line, yes. At the fourth line, yes. Which means that 1011 is equivalent to this one or not? Means here the another advantage of decoder is, which is meant for user to represent as ROM. Means that if you would like to store certain data, we can store, and whenever we request it, by passing certain kind of data, like for example here if you observe, I passed as 10 as input, I got the respective 1011 as output. This is what storage mechanism. So where we are going to store something, I can call it as ROM mechanism, read only memory, right? For example, I am simply passing, I need to get the data as 0011. Then what data I can able to pass here? I can able to pass simply 11. If I am going to simply pass 11, the power is going to transfer at this particular line, and already these are connected. If it is connected, it is going to get the high output. It is going to connect the high output, and these two are not connected, so you are going to get 0011. Right? So simply I can say that the decoder I can able to use it for the ROM matrix. Okay, fine. So but the question here is, how many connections are required and how many links are required in order to implement this particular requirement? Connections and links. So links means what? The interconnection between a row and a column. The interconnection between a row and a column, I can call it as simply a link, right? So if I say this one, this is one link, right? So how many links are required now for this particular requirement? How many links are there? 16 links are there. You can able to directly understood. 2, 3, 4, 5, 6, 7. So like this, it is a kind of a 4x4 matrix. So we are going to get total 16 connections. So total 16 links. And how many connections are there? Connections means number of inputs and number of outputs. Number of inputs and number of outputs, right? So what are the inputs are there? The inputs are like 4 lines are the input. 4 lines are the inputs, and total outputs are 4. So total you are going to get 8 connections. You are going to get 8 connections. Okay, fine. So for example, if I am going to have a 2x4 decoder, and I am going to have 4 lines as output, and there will be 3 functions. So now, can you tell me how many connections are required, maximum connections are required at this particular requirement, and how many links are required. Links means what? Each and every interconnection, right? So you may observe at the horizontal line you have 3 interconnections, at the vertical line you have 4 interconnections. Can I say that it is 12 links? What about the connections? 4 as inputs and 3 lines as output. So can I say that 7 connections are there? Yes, right. Similarly, if I am going to generalize it, if I would like to generalize it, how can we generalize this one? Right? If it is a kind of like let me take, instead of taking 2 by 4 decoder, I would like to take it as n by 2 power n decoder. N by 2 power n decoder, and assume that m functions are there. Assume that m functions are there. Then how many connections are required? M plus 2 power n. Very good. How many links are required? M into 2 power n links are required. So I hope you understood with these examples, right? Okay, now fine. So here, so the point here is number of output lines are 2 power n. Output lines are 2 power n, and number of functions are number of vertical lines. So that's why number of vertical lines are m, and number of output lines are 2 power n. So m plus 2 power n is the number of connections. Similarly, number of links means what? So each and every interconnection, which means m into 2 power n. 2 power n. Okay, fine. There is another advantage of decoder is there, that is address decoding. Address decoding, which means that we can able to, so with the help of this decoder, I can able to decode the addresses of various kind of devices. Like for example, if I am saying that a particular device address is ranging from 0 to 9, the particular device ranging from 0 to 9, then I can able to make it root for this one. So then I can say that it is called as address decoding, meaning that it simply selects various kind of devices based on the addresses. Simple, if you want to say in simple words. Okay, for example, let me write a question. If A3, A2, A1, A0 are addresses, you can note down, are addresses, then what range does D1 and D2 decoder represents? Okay, and they have given a circuit here. The circuit will be look like this. It's a kind of 2 by 4 decoder where you are going to have 2 inputs, and basically you may have enable line, right? So this enable line is always going to be 1 to get the respective output, and they have defined 2 more devices. One is D1, another one is D2 of same size, 2 by 4 decoder, and another D2 is also 2 by 4 decoder, right? So they connected like this. These 2 are enable lines. And if I say that it is 2 by 4 decoder, how many output lines are going to be there? 4 output lines are going to be there, right? I mentioned 4 output lines. Now if I am saying that at D1 you are going to have, I don't know exactly how many output lines are there, but they mentioned it as 2 by 4 decoder, right? So the question they have asked is, what range does D1 and D2 decoders represents? What is the meaning of it? Right? What is the output that is produced by D1 and D2? Can you observe? So guys, try to make understood. Can I take this as A3 and A2, and this is A1 and A0. This is also A1 and A0. Right? Fine. Now, in order to get the output of the D1, what you have to do? What might be the values of A3 and A2? Can I take it as 0 and 1? If I take 0 and 1, the respective D1 circuit is going to be enabled. Means A3, A2 are going to be 0, 1. What about A1 and A0? Right, if this circuit is going to be enabled, what might be the outputs? 0, 0, 0, 1, 1, 0, 1, 1. So it is going to ranging from 0, 1, 0, 0 to 0, 1, 1, 1. So this is the particular range. So total 4 values you are going to get. Right. Similarly, to get the output of the D2, what values you have to pass here? 1, 1. If I pass 1, 1, for D2, A3 and A2 are 1, 1. And what range of A1 and 0? It should be 1, 1 and 1, 1. So here also it is going to have 4. Which means that the range of the addresses are from 4 to 7 and here is from 12 to 50. So this is the respective answer for the given question. So this is the way you can able to use address decoding mechanism also. Right. So if I conclude, right, so we have seen various kind of advantages of decoder. What are those? First one is you can go with any kind of basic logic circuits. What is another one? We can able to make simply converse from one kind of input data to another kind of input data. See, it means that it's not only about for all cases. So you have to go with only for few cases. Like if I am going to take simply BCD to decimal or binary to octal, like that you have to take. And parity checker is one of the advantage. And another one is it can act as a ROM matrix. And another one is address